Welcome to orthogonal trajectories in physics. So there are a couple of places where orthogonal trajectories are key things in physics. So the first place we're going to look at is isothermal and heat flow. So let's consider a two-dimensional plane. And specifically, we're going to consider the temperature. In a two-dimensional plane. With temperature given by the function u of xy. Then isothermals are curves where the temperature is the same. So isothermals are curves of identical temperature. And they're given by u of xy equals a constant c. It turns out that maximum heat flow travels perpendicular to the isothermals. And so since the heat flow is traveling perpendicular to the isothermals, we can use orthogonal trajectories to represent maximum heat flow. So that's one place. If you know the equations for the isothermals, you can solve for the heat flow by solving the orthogonal trajectories. Then in another place, we look at equipotentials and lines of force, which has to do with potential energy. So here, we'll look at the potential energy of an object being acted upon by a force. So we'll consider the potential energy. Oops, sorry about that. The potential energy u of xy of an object being acted upon by a force. In an xy plane. Then the equipotentials are the curves of identical potential energy. And just like with the isothermals, equipotentials are just given by the equation U of x, y equals C. In this case, the orthogonal trajectories are called the lines of force. So these are just two places in physics where you will run into orthogonal trajectories.